Hey, Susan.
Hey, Christina, let's work one more hypothesis test with on means, but let's use data this time.
Yeah, I think that's a great idea.
Okay.
Okay. So you receive a brochure from a large university. The brochure indicates that the mean class size for full-time faculty is fewer than 31 students. You want to test this claim. You randomly select 18 classes taught by full-time faculty and determine the class size of each. The results are shown in the table below. At a 0.01 significance level, can you support the university's claim? Okay. So this is a situation where I'm given a set of data. Now, I could use summary stats to find
The sample mean and the
sample
sample
means.
standard deviation.
Yeah, or I can just go to, or I can just go to t-stats.
Just like we've done. Just like we've done before.
One
Except
sample
instead of saying with summary, say with data.
with data, right?
Okay.
Okay. All right, so we've entered the data in the StatCrunch. Notice it's in a column, right?
Yes.
Remember that you have to put all of your data in one column.
Yes.
All right, and then
We haven't done our claim and stuff yet, though. So can we
right,
set up our? We might need to make this bigger and make our
yeah,
do our claim. The claim is less that the mean is less than 31. Okay.
yep, that doesn't have an equals,
Oh,
so
it's the alternate again.
it's the alternate.
You know, guys, all of our videos had it as the alternate. It's not always the alternate, okay? So pay attention.
It's not.
So this will be a left tail test.
Yes, this would be a left tail test.
Okay.
Okay, and
And alpha is 0.01.
yes,
Okay. Let's do it.
yeah. So I'm gonna go to stat. T-stats, one sample, but with data, which is actually the first option.
Yes.
Okay. Now I put that data in variable 1. I don't know.
Now we don't know what to do.
Well, I don't. What happened? This thing hates me. Variable 1. Okay, it's there. Right? Okay. And so the null hypothesis, I'm going to put mut equals 31.
Okay.
And then for the alternate hypothesis, I want to make sure that's left tail, so I'm going to put less than.
Okay.
Okay. I'm going to show the critical value.
Absolutely.
And that is 0.01.
Oh,
So
yeah.
you
You
can change
reset that significance level to what alpha was. Okay.
Yeah.
Okay.
Yep. And then I should be able to hit compute. Okay. And so that's where I'm getting my critical value. I can get my test statistic and my p-value.
And we have those written down on the key, and they're correct. So hey, look at us.
Yeah. So let's make sure that we remember how we're going to
Use those.
use those. Right. Right. So if I draw out my t-distribution here. Okay. The critical value is in the left tail because it's a left tail test.
Yep.
Okay. And that t critical value was negative 2.567. Okay.
Okay.
And then the test statistic,
Which is the t-score for our sample data.
yeah, that test statistic we got was negative 1.35. Okay. Well, if 0 is in the middle,
Oh, that happened.
here we go. If 0 is in the middle, negative 1.35 is not going to be in the rejection area.
No, it's not.
It's going to be out between 0
Yes.
and negative 2.5. Okay. So also the p-value.
Yeah, let's check that too.
Right. That p-value, which is all of
From
that.
your test statistic all the way to the end of the tail.
Right. That p-value was 0.0 0.973.
Okay.
That's definitely greater than 0.01.
Oh, yeah. Can we mark the 0.01 on our graph just so we would know, just so we remember that that's what that was. That's what that area was.
Yeah, so this area here, beyond my critical value, is my alpha of 0.01.
So, yeah, clearly that p-value area is much larger than the alpha area was. Okay.
Yep. And so since we failed to reject the null hypothesis,
Look at your table in your formula sheet to make sure you can come up with this statement about the claim.
and our alternate hypothesis was the claim, okay, then there's not sufficient evidence to support the claim that the mean class size is less than 31 students.
Okay.
Okay, so yeah, use your table to write that. So even though that sample mean was less than 31, it was not significantly less than
That's
31.
a very good point. Can we mark 31 on our bell curve where the 31, this is what our claim would have been. So 31 is where our null was, and that's just the mean of that bell curve. And you are exactly right. We ended up with something less than 31.
Yeah, it was like 29.8.
Okay. So it's hard to say without doing the hypothesis test. Because you're
Right.
like, yeah, it's less, but is it significantly less?
Right.
Yeah, good point.
All right. Well, I think that's it.
Okay.